analysis. Again, just for your memory, that this topic belongs to a topic in mathematics called numerical analysis, or sometimes also referred numerical methods, when more application problem will be discussed. Although we also have to discuss the application problems, but at the initial phase we just need to give the concepts about how we can use this topic. So the first topic, it is very easy topic as well, is called error analysis. So what we have to cover in this topic and how we will discuss now. So what is error first? The question that we have to answer first, what is an error? The answer that we have to give here is based on, in fact, a point that we have to see is from mathematical perspective. Yes, the error we can refer as a mistake or a blunder during the calculation that we made. But what exactly the error is for us in the sense of the numerical analysis, and how we can quantify those error during the calculations. So just for idea, just for the sake of idea, a mistake can be regarded as an error in general, but in a logical sense or in a proper definition, the error could be defined as error is the difference of two quantities. One is called exact quantity, exact value, minus approximate value. This is the formal way to express the error. So what is simple definition of error? Error is the difference between the true value and the approximate value. Let's call the error, let's call the a true value by a, let's represent the true value by a symbol y, and the approximate value by a symbol y hat y. So this is basically the definition. What does this mean? For example, there is a metallic bar, and you want to compute its length, horizontal length. So you are using a measuring tape and you try to count it from there to there. So if you look carefully, while I am extending the measuring tape, I made a mistake. What mistake? Instead of starting from this part, just to compute the length, I started a little bit earlier. So if I will get any reading from this measuring tape or a length of a, just imagine a tape or a length. So it will give me a length, but necessarily this length is not the same as the length of the metallic bar I want to count. So what will I do? I will what this example has to do with our example. So the actual length, this is this part starting from exactly from there and ending exactly there. If I want to compute that length, then this length is refer as a y, the exact value, actual value, and the length that we have computed from there to there. So this part, sorry, so this part is clearly reflecting I have counted something extra amount there. So that complete length from there to there, that complete length is referred as a y cap. So if I compute the difference between y and y cap, certainly I will get some difference amount, and that difference amount in this example can be regarded as an error. So if we discuss what does the numerically or the means that you are having error in your calculation, which means that you have a difference between the actual value and whatever you have computed. So the example that I gave you above is just a practical example that you have a metallic bar and you want to compute its length. So there is an error in this calculation. So exact and approximate. But in mathematics, usually we do not have a practical scenario. So what we have a mathematical point of view. What is the definition of error from the mathematical point of view? It varies case to case. For example, if you want to discuss or read a function, for example, there is a graph of a function which I hope you all know how to create. For example, x values, y values, and there is a function, some function, let's say y equal to f of x, and this is the origin. So what I did, if I compute, let's say I select a value a somewhere there, and I want to read this function. So the exact value that I can read from this function is by plugging this value a, into this function. So the correct reading of this function at point a is f of a. This is, in our case, is y, that is exact. This will regarded as a exact value. But let's say somehow I made a mistake. Instead of reading this reading correctly, I noted some other reading. For example, I noted somewhere there. So I noted this height due to some reason, which I will explain later. So if I have this reading and I said that this is the value of the function, so one can clearly see this is not true. There is some sort of mistake in calculation, or there is some error, in other words. So how we define the error in this case? So in mathematical case, so we can define error like that: the difference between the exact value of the function and the approximate value of the function at a particular point. In this case, the point is a. So what will I call this value as a y cap, this height as a y cap, and this point, this value as a, from there to there as a y. So if I compute the difference, I will get the error. So error exists in many forms and many shapes. Like we cannot get rid of error, especially when we are discussing numerical analysis. And because in numerical analysis we try to solve the problems that are not easy to solve by analytical approach, and we try to solve it using approximations. So whenever we apply this strategy that we want to solve a certain mathematical problem using approximations, this means that we are going to solve something with approximate value. So when you are solving anything with approximate value, then there is another point that you always have to be in your mind: what error it will bring to our calculation. So this is the main point. So I hope you all are already aware of the error concept, being an engineering student or final year. But this is just to connect the things, that you have a one thing which you call exact, and the other thing that you called is approximate. And if you compute the difference of these two, you are saying basically error. So it is very simple idea. Now, student, for example, for example, uh, in a certain calculation you have the following error defined, like error equal to, let's say, 10 minus 10 is the exact value, and let's say 10.1, where 10.1 is the approximate value. So you made some calculation, the exact answer would be 10, but somehow you are getting 10.1. So this means that there is an error, and the error amount in this case is 0.1. Simple. Calculation in this example is very simple because we know exact reading and we also getting the approximate. But in real time, and usually in the practices when we have to discuss numerical problems, we only have an approximate solution. But the logic by using we are computing the approximate solution contains some mistake. We usually have a confidence that okay, this calculation contains some mistake, but whatever we are answer is getting is approximate, but we don't know the exact reading, because if we know the exact reading, there is no need to perform the approximate calculation. So this means that usually we cannot quantify the error in this simpler or easiest way. Usually this value is missing, because if we know the exact reading, there is no sense to apply the approximate value, because you can use the exact reading. But there are many problems in which we cannot compute the exact values or exact readings, so we will try to approximate the solution. For example, let's have an idea. For example, I will give you this example from a very basic concept, and that topic or a concept is called roots of equation. If you remember, roots of equation. So in case of root of equation or roots, it may be a more than one if the equation is non-linear. So for example, if there is a non-linear equation, let's say y equal to f of x. So if I want to compute its roots, so basically what I want to do, I want to find the value x belongs to its domain such that f of x is equal to 0. So I want to find the value of x such that f of x is 0. So how I can relate this with the concept of error and other thing. So let's say there is a graph of this function and I want to compute its root. So let's say I'm just plotting it in a first quadrant. This is the graph of a non-linear function which I showed there on the left hand side. So one can clearly see the root of this function. Root of this function. Root of this function lies somewhere there, because at this point the value of the function goes to 0. What does this mean? If I select any point here and try to compute the height, I will get certain positive value. And if I select any value here and try to get the height of this function, I will get negative value. But this is the only point roughly that has a value of y function equal to 0, because it cuts the x-axis. So I can say by visualization that this point, let's refer it xr. Let's call it xr. xr is a root of this equation as per our geometrical understanding. But we all know that we cannot compute xr by just looking this graph, because the graph is a non-linear function. So but we have this following assumption that fxr is exactly equal to 0. Now if I ask you to compute this xr, is there any way? So there is a one method called, you can apply different numerical techniques, because there exists no exact technique to compute the root. But just for an idea, I will give you an example. For example, this is the function x square minus ex sine x minus or a plus 4. This is a non-linear function, are also called transcendental function. For example, there is an equation x4 minus 3x square plus 4x minus 9. So this is also a non-linear equation. This is a polynomial. So you can clearly see you cannot compute the root by just looking that function, because there is no analytical method that can answer the roots of this function. So you have to think something differently. For example, you are doing some engineering calculation, you end up with this equations like these two equations or any one of this equation, and you want to compute the root. So obviously you cannot compute the root. What you have to do, you have to try to solve it, or you have to give up your problem. So if you try to solve it, you cannot find the root exactly. You have to go for the approximations, that how I can go closer to xr. If I can find xr, that's good, But if not, then I want to go closer to XR as much as possible, so that I can claim that value is very close to the root, although it is not root. For example, I'm not going to discuss the different methods here. For example, I apply a certain method and manage to find this point, let's say this point. Let's call it x dash. Do you think this x dash is a root? No, because x dash is having certain height. For root, the point must be equal to 0. So what I can say in this case, I can say there is an error. There is an error in my prediction. There is an error in my prediction because the exact reading is XR, or actual value is XR, minus the approximate value. In this case, the approximate value is X dash. We are not interested how we compute X dash. There are different methods like bisection, Newton-Raphson, secant, false position that we can apply to find the approximate root here. But the point is, this is the exact value from the graph, but we cannot compute that value. And this is something that I obtain in approximate. So I can clearly see this is not the exact answer. There is some amount of error exists between these 2 points. So what is the quantity of this error? That could be reflected by XR minus X dash. Now student, the same point exists. If I know XR, then there is no need to compute X dash, because if I have to find the root of this problem and I know the roots, then I do not need to apply any approximation technique. But in reality, we usually do not know the roots. That is, if I ask you to what is the value of X that make it 0, or what is the value of X just make it 0, you cannot say by just looking this graph easily. You need some methods to find. And unfortunately, for higher degrees, greater than 2 or something, and the transcendental equation, we do not have exact method to finding the root. We need to approximate the solutions. So whenever we approximate, then there is must be a chance that our answer is not 100% correct. It contains some amount of error. So how do we define the error in this case? We say the exact root minus the approximate root. Keep in mind that words will be changed according to the situation. Here, error is exact value minus approximate value in general, but here I can say also exact root value minus approximate root value, which is obviously contains some error. And one can clearly see if this quantity goes to 0, I mean the difference between these two goes to 0, then one can clearly say that we have reached to the exact value of the root, or very close to the exact value. This means that error close to 0 is a good thing. Now student, one can clearly note down in this case, if this is an example, X dash, if I subtract XR from X dash, XR in this case is greater than X dash, because this lie far from it, from the origin, so XR is greater than X dash. So if I compute the difference of these two, it will be a positive quantity. But one can also assume that if I try to find the approximate root of this function by using any method, which is not the concern at the moment, the approximate value may lie somewhere there as well. For example, X double dash. So if I try to define the error in this case, so I have to say actual value minus approximate value. So in this case, I will get the negative answer, because a negative error, because the approximate value is larger than the exact value from the origin reference. So this means that error could be positive and negative. Although positive and negative here does not means that it is decreasing or increasing, it is just representing the direction at which the approximate root lies. Because this is the exact root, then it could be on his right hand side the approximate root, or approximate could be on the on the right hand side, and approximate could be on the left hand side of the root as well. But keep in mind that we don't know this quantity in general. So what we are referring as, okay, this is our root. So I hope you have some idea now that whenever we say we want to compute the difference between the actual and approximate, and we call it error, this is just a mathematical definition. But in most of the problems, we don't know the exact reading, because if we know the exact reading, there is no need to compute the approximate value. Hence, there is no question of the error. So that's the main point. So keep in mind that this is just a definition point of view. But sometimes we know the exact reading when we are comparing different methods or something. So in that case, we can compute the error. Then the question is now this problem that this example, this is basically example of what does actual means, approximate means, what the error means is. Now the question is